recorded and then put up on YouTube and in Schoology. So, but they don't miss anyways. But you know, if they want to do some review at home, then here it is. Okay, this stuff is all over the test. I was looking at a draft of the test, and I was thinking, God, have we taught inverses yet? Because there sure is a lot of that. And, oh, that's tomorrow. Okay, so relation. Relation between variables can be described mathematically with, there's a number of ways really. So a set of ordered pairs, a table of values, that's not in there, a graph, an equation. Here are some relations. Some of these relations are functions. What makes a relation a function? You don't have to answer because it's right here. And you can read, right? So a function be defined as a rule. Okay, but you can read, therefore. Go ahead. What? Wait, do you want us to read or read? Okay, go ahead. Yeah, that's the idea. See this pile here? Okay, so you know what the function is? You can use the vertical line test. You just can't define a function by saying it passes the vertical line test, right? That's not good enough. So you have to actually state that every x value has, the value of x is paired with 2 or more. So for each x value, there's only one y value. Inverses of relations. The inverse of a relation results when the two variables are interchanged. So if you've got a set of ordered pairs, 2, 3, 3, 4, 1, negative 5, the inverse would be what?
3, 2.
3, 2. 4, 3. Negative 5, 1, right? A relation is described by the equation y equals 2x plus 3. What would we do to get the inverse? Yeah, you guys are pretty good. Noisy. Yeah, good. However, we don't write stuff in the form x equals, although interestingly, Desmos will very happily graph that for you if you want. So, if you're checking, if you want to check your homework on this, I mean, you have to know how to use the graphing calculator, right? Because that's all you're going to have with you. But if you want to check some stuff over and you're working at home and you open up Desmos, you can graph y equals 2x plus 3, and you can graph x equals 2y plus 3. But we need to express this in the form y equals, if at all possible. So the inverse equation must be rearranged so that y is isolated. So we have y equals 2x plus 3. We said the inverse is x equals 2y plus 3, and when we isolate the y, what do we get? We get this, right? So you just solve for y. Okay? So you take the inverse relation and you solve for y. Any questions on the first page? How many pages are there to this thing? It's like, I know, eh? I looked at it yesterday. Oh my God. How long will this take us? Okay, relation is described by the, less time if only one of us is talking. A relation is described by the equation y equals x squared. The inverse is described by the equation x is equal to y squared, which then we isolate the y and we get
Y is equal to the square root of x.
Well, not quite. Well, yes, but not completely. What are you missing? Plus or minus. So, to find the equation of the inverse of a relation, you interchange.
X and y.
Although you could have written it y and x. But yes, we'll write it x and y. You interchange x and y in the equation of the relation. Rearrange the equation of the inverse so that
Y
is isolated. Another way to say this is solve the equation of the inverse for y. We're going to solve for y. Okay, so that's if we have an equation, right? And you can handle a set of ordered pairs, right? And you can handle a table of values, because that's just a set of ordered pairs in a table. So that's kind of the same. Okay, example. Graph the relation y equals 2x plus 3 and its inverse, y equals x minus 3 over 2, on the grid below by completed table of values shown. Okay, that'll fit. Okay, so I don't know. What age were you when you started doing connect the dots?
2.
2? It's like being 2 again.
What?
The only problem is you always behave that way.
I blame Logan.
Yeah.
Okay.
No doubt. All right, let's do this in green. Now, here, I'm going to show you how to, what if you're given the graph and you have to draw the inverse? Then what you do is you just take the point on the graph, right? So I take this point, -3, -3, and I interchange x and y, giving me the same point. And I take this point, -2, -1, and the inverse will be -1, -2. So that's here. And I take this point, -1, 1, which becomes 1, -1. And 0, 3 becomes 3, 0. 1, 5, 5, 1. 2, 7, 7, 2. Plus 3, 9, 9, 3. And I draw a line, and what do I do with the line? And at what point will all 28 of you learn to draw arrows on something? Yep, yeah, never is yet. Never is probably the right answer. Well, yeah. When grass grow wings and fly. Note that'll. Oh, you got it done. I gave you a head start. So note that a line was already graphed on the grid. What's the equation of the line on the grid? Y equals x. And what's coming next? There must be something.
They're the same.
They're the same. Nah, it's not. Unfortunately, it doesn't fit. It's a long time. They're the same. Doesn't work. What do you notice about the graph of the relation and the graph of its inverse relative to the line y equals x? Yeah, it's a reflection. So they're symmetrical around the line. So symmetrical, which I probably can't spell. Symmetrical.
Line of symmetry.
With respect to the line y equals x. But what we're really going to say, it's a reflection around or about the line y equals x. So reflection about the line y equals x. Okay, because you're going to do a lot of that in 30-1. Right? There's be a lot of reflections. Okay, Cran, you're actually writing. It's got to be physics or something.
Oh, it's so. Oh, okay.
Is
good enough.
Is the inverse relation a function?
Yes.
Yes. How do we know?
Vertical line.
Yeah, vertical line test, right? Which we won't use to define a function, but we can use okay, that's a function, right? Sort of the Q and D, the quick and dirty. Hey, so when you're solving algebraically these equations on, what day is the test? It's like Monday or something? Monday. So on Monday, when you're solving these equations algebraically, you don't have to verify them algebraically, right? But you do have to boot out the extraneous solutions, right? So at the end, you're going to give me a solution set. Right? You say the set consisting of, put the numbers in there, right? Or write x equals, but let's go with the sets. You know, why not? Get a little practice with sets. When you give the solution set, leave out the ones that aren't really answers, right? But you can verify those graphically, okay? You can verify them algebraically. I'm not saying, you should, but I wouldn't waste a lot of time doing it necessarily, right? I mean, you can just graph them and say, okay, yeah, there's these, it's these two, but not these two, or whatever, right? And I'm kind of fighting to get more room in some spaces. So bring some paper. You want to write on paper, you bring your own paper, okay? I'm not supplying paper. The paper cow is dried out. I don't even know where my paper. I think it's probably been taken by all you.
I bet it's got.
Do you think paper goes on trees?
Okay, graph relation y equals x squared on the grid below by complete table values shown. Okay, so I guess we gotta do that first. So I'm gonna move that there. I'm gonna pause. Okay, so we're gonna draw, and then what am I gonna do? Arrows. Yeah, you'd think that. And now we want to graph the. Yeah, I know the questions. I don't care if the question had arrows. That's not the point.
You should mark the worksheets. Yes.
All right. So when x is 9, I've got -3, but I also have +3. And when x is 4, I got -2 and +2, and I've got 1 negative.
And it looks like a parabola. Well, actually, just.
Okay. Are we good? Oh, look, the numbers are counting up, so that must count for something. The equation of the inverse relation is this one here. Yeah, okay. So it's x equals y squared, which can also be written as. And you're not going to forget the what?
Plus or minus.
Yeah, you will.
Yeah, we probably will.
Well, some of you will. The same number that forget arrows, right? It's a correlation. I'll see if I can run a correlation. I'll keep a little checklist. Forgot arrow, forgot plus or minus.
You should write on the board.
Yeah.
It's like checklist before you do the test.
Forget not arrows nor plus or minuses. Notice the line was already graphed on the grid. The equation of the line is? What do you notice about the graph relation and the graph? It's inverse in relative to?
Same thing on the last page.
Okay, it's a reflection, right? About the line. So it's like you put a mirror there. Or a mirror. You guys ever see a mirror?
Yeah, we used it in like elementary.
Did you? Yeah. I think we might have some around. I don't know.
Use those in Portelli's class.
Oh,
They're like the red things and a little wooden thing. You put it down, you can sort of see through it, but see the reflection in it.
I never.
Right? Really? Never? See if I could dig one up.
Oh, yeah, the red thing. That, like,
Yeah, the red thing with the things. And is the inverse relation a function?
No. Vertical line distance.
No. So, this could come in handy on Monday. I mean, this whole thing will, because there's a lot of this inverse stuff out there. No, but so if the domain on the original function were restricted in such a way so that its inverse was also a function, what would the domain have to be restricted to?
Only positive. Yeah, only positive.
Positive x. So could you include 0?
Yes.
Okay. So if we restricted the domain to this, then this is what we would get. But is that only?
No.
So what else could you do?
Negative.
You could also restrict the domain to, which would then give you. But is that only? Really?
No.
So if I said the domain was x is greater than or equal to 17, would that then give me a? Yeah. I mean, it's not the most, but it would give me one, right? So there are many, but we're going to go with, let's try and get as much as we can. So x greater than or equal to 0, right? Or x less than or equal to 0.
XOR.
X, yeah, it's an exclusive or. Which means what?
Which means one or the other.
Yes.
Huh. Yay, computer logic. Minecraft.
Yeah.
No.
Notation.
Oh.
If the inverse of a function is also a function, the inverse is denoted by f inverse x. This is read f inverse x, which does not mean 1 over f of x. Right? So when you see this, it means it's an inverse function, not that it's this, right? Because if you see x to the negative 1, that is 1 over x, right? But this is not the case with a function. He said, then expecting you to remember it because now it's gone. This notation can only be used if both the relation and its inverse are functions, right? So that could require you to then restrict the domain to say, hey, if x is greater than or equal to 0, then the inverse will also be a function. Can we say? No. Can we say? Well, I think so. Yes. Can we say? Watch, I'm about to say it. Determine f inverse of x if f of x equals 2x plus 3.
Yes.
Yeah, we can say that. You just did. I don't know. What is it?
Yeah, you just.
What should this really say, right?
Is this possibly say true?
How about determine f inverse of x?
Explain.
Can we say? Well, I don't know. Okay, so will this be a function? I guess that's what it's saying. So is the inverse of this a function?
Yes.
Yes.
Because we just did it.
Yes. See above. Or other page. Other page. Or back into earlier.
Just write yes, no on the test.
Or other page.
In the video.
Oh, the test? Yes, reference the video.
Drag
Yes, refer to the video.
Drag.
No, actually, write the website perfectly.
Yeah, HTTP.
Is it? It's like HTTP.
Okay.
Oh, I thought you said drag.
Well, if you've got the timeline, you can just drag back, right? Can we say, okay, so is f inverse, can we find the inverse function for this?
No.
No, why not?
Because it's positive.
No, the inverse is not a function.
9.
9. Not a function. Can we say determine f inverse of x if f of x is equal to x squared and x is greater than or equal to 0?
Yes.
Yes. Why?
Because
In
it's a
that
function.
case.
Yes, because then it is a function. Because then the inverse
Should be equal.
is a function. Practice. What? We done?
Oh, we're done?
No.
Oh, we are.
I don't know. We can't be done.
What's practice?
Oh, there's practice.
It is practice.
How much practice is there?
There's a part F.
And then there's a part F.
Tons of work. Oh, no, that was.
Where's part F?
On the next page.
Yeah, I don't have the next page.
Really?
Unless it's down below this. Oh, wait. Here it is. All right. Well, so let's do a little practice. It's okay. Pick one.
12.
Well, let's do one of each. So we'll do... This way, at least I know some of this has been done. Complete the following chart. So we're looking at graphs. Keep in mind that y equals x is graphed for you, right? Just as a courtesy. So that's not the one we're trying to find the inverse of. What's the inverse of y equals x?
Y equals Y.
Which is?
Y equals X.
So it's kind of self-inverse.
Y equals X.
So that'd be sort of silly to ask you to do the inverse of that, right? Okay, so relation, domain, and range. What's the domain?
X is a real number.
X belongs to the reals. What's the range?
Y belongs to
Y belongs to the reals. Function or not?
Yes.
Yes, or function. Inverse of relation and domain. Graph inverse on grid shown. Okay, so we're going to do that by finding points and then doing what? And then interchanging them and then graphing, right? So we're going to say, I have the point. Now, when you're doing more complicated stuff like this, you're not going to do every point, right? I mean, because how many points are there from here to here? Infinitely many. And how long would it take you to?
infinitely long.
Yeah, a long time. So you need to do important points, right? Okay, so that rest of that one is boring, so I'll stop there.
Wait, what?
I see a box.
Let's do this one here.
That's a
So this, I'm not going to do domain range, let's just graph the inverse of this. So how are you going to do it? How many points are you going to find to graph the inverse?
3.
3, right? Now, I find it handy when I'm doing inverses like that to do a point and then do, so for example, this point is -1, 3. So we're going to, so the inverse is? -1, 3.
Yeah, 3 -1.
So 3, -1. That's here, right? It's joined to -1, 1, whose inverse is? 1, -1. And so it's joined, so I'm going to plot that point, and then I'm going to join these guys, right?
Oh my.
No arrow needed. No
Okay?
points.
No arrow. Right.
Math and action.
Yes.
And then this point is
It's a
-4, 1, whose inverse is? Okay. Now, the reason I do that is sometimes we get a reasonably complicated figure, which this is not. And if you just do all the points for it, it might be a bit hard to determine now, okay, wait, how do I join those points up, right? So I like to, when I'm doing these types, is do the inverse of 1 and then something that's joined to it, join them up. And then you can look and say, yeah, okay, I think that would be a reflection of that. And maybe if I can dig a mirror or two up, I could bring it, and then you could lay it along here and look and say, look, I got it right.
What is this?
Yeah, and the other thing is you can fold your sheet in half and hold it up to the light. Don't do that during the test. You say, could I step out in the hall and go fold my sheet in half and hold it to the window to make sure? Okay, and then this is just points, so its inverse will be also points. Is this a function?
No.
No. Will its inverse be a function?
Exactly.
Maybe, we don't know. It's hard to tell, right? Because we don't have it all done yet. Set of ordered pairs. That's kind of easy.
Not a function. Why can't it English?
What else we got? Maybe I'll be nice. I'll post a key to this. How would that be? Yeah.
Would you post it?
No. I'll stick it on the back. I'll stick it on a board. I need to bring more magnets in, I think.
Magnets.
Yeah. Do we have to do anything with this guy? Right.
Yes, totally.
Really?
Yes.
Inverse of that.
Is this the same as your worksheet?
What's the domain range for this?
Why? Oh, okay. So notice there's a restriction on here, right?
2G.
Yeah. Let's just do part F.
Oh.
Why
What's 2F?
there's two F's.
And there's 2 J's.
There's two J's. I have no idea.
Letter's too strong.
So I give up. We're going to part F. Well, you can do it. Besides, it's for you anyways. Practice. Determining whether pairs of, and there's a lot of this stuff on the test, which is when? Monday, right. What do we do tomorrow? Oh, vectors. Oh, these are different vectors. They got like, you won't even recognize them. Well, I mean, they do have magnitude and direction because that's what makes a vector a vector. But. Oh, and word of advice, I mentioned that we were starting vectors to my daughter, who said, make sure that you keep your notes because you will be tested on vectors. I mean, there's a vectors test, but the next time you're going to see vectors, it's going to be a year from now or 2 years from now.
Physics.
Right? If you're doing forget physics vectors, nothing to do with it. If you are doing standard level, you will be writing your IB exams in 2 years. Or sorry, in a year, right? Next year.
2 years.
If you're doing higher level, it's 2 years. Okay? Because you don't do your IB exam until grade 12. You are not going to see vectors between now and whenever you write. So that's 1 or 2 years. So keep good notes, hang on to them, right? Because that's the next time you're going to see it. That's going to be a year from now. So.
Just to laugh at you guys.
Okay. Anyways, determining whether pairs of functions are inverses of each other. Two functions are inverses of each other if one function undoes, really? Undoes. What's English such an easy language, right?
English.
You should teach us Chinese.
What? Yeah,
I'm
which is now.
Chinese. Just teach us. There's only
That's your
3,000
cue.
words. Yeah.
No, I said English such an easy language, which you say?
No English.
Right. Okay, so, we were here, right? Undoes and vice versa, right? If they are self. So this is, I said this yesterday, right? F of g of x is not the same as g of f of x unless they're inverses, which you didn't even know what that meant yesterday, but now you do. So, show that f of x equals 2x plus 3 and g of x is equal to x minus 3 over 2 are inverses of one another. How do we show that? Well, we have to do this and this, which I believe is also on the test. There's somewhere.
That's easy. We should be.
So it's going to be f of... Okay, so what do? We say f of g of x, and where we see g of x, we write in the definition for g of x, right? Which is x minus 3 over 2. And now we do f on that function. So what do we do? 2 times, which is equal to,
That's very yes.
right? So I strongly suggest that they are inverses, but I must also do, maybe you just fluked into a function where, when you do f of g of x, you do end up with x, but if you do g of f of x, you don't. So this is g of 2x plus 3,
Minus 3.
and g says to do what?
Oh, put it.
Go 2 times
Oh, 2.
2x plus 3
Yeah, that's what I said.
minus 3
Over 2.
over 2, which is?
X.
And so they are inverses of one another. Okay? Example, show that these are not inverses of one another. Do I have to show both if one doesn't work? No, right? Because how many counterexamples do you really need? One, right? One counterexample will suffice. So this is f of x plus 3 over 2, which is what? 2 times? not inverses. Or, as one would say, no inverse. As it ripples slowly through the class.
When you always jokes about me, yet I took like 4 hours to get it.
Yeah.
It's so sad.
What? Oh, ha ha ha. Now somebody in the back is now going to laugh. Okay, so, have I got all the homework? Do I want to do this again? Okay, here's what I'm going to do with this. I'm simply going to add 1 mark to the test. This will be out of 1. You're either going to get 0 or 1. I'm going to add 1 to the test. It's going to make no difference in your mark. You realize that, unless you didn't hand it in, which will make a difference in your mark. Okay?
1%.
Oh, what? Somebody didn't do it?
Oh, no, I haven't yesterday.
Oh, well then, what are you worried about? Then you're all good.